Hi everyone, we're going to locate the absolute extremum of the function on the closed interval here. And the first thing I'm going to do is find any critical numbers. So I'm going to take the derivative of my function and get 3x squared minus 2 times 3/2 x. And it's going to be 3x squared minus 3x. I can factor out a 3x and get x minus 1. So to get your critical numbers, we're going to set this to 0. And we have 3x equals 0 and x minus 1 equals 0. So here x is 0 and x is 1. So we want to know this point because it could be a minimum or maximum. So I plug in my 0. When I plug in 0 to my original function, excuse me, f of 0 is going to be 0 minus 0, which equals 0. If I plug in 1, I'm going to plug in f of 1. That's going to be 1 minus 3/2. And I can change this to 3 over 3. So that's, or no, I can't change it to that. Change it to 2 over 2. And because that's 1, you get negative 1/2. So our two critical numbers are going to occur at 0, 0 and 1, negative 1/2. So those are two critical numbers. Now we also have to evaluate the left endpoint and the right endpoint. So let's do that. So we're going to evaluate f of negative 1 and f of 2. F of negative 1 is going to be it's negative 1. And that's going to equal negative 5/2. And then f of 2, we get 2 cubed minus 3/2 times 2 squared. And that's going to give you 2. So when I write out my numbers, I'm going to have my left endpoint is going to occur at negative 1, negative 5/2. My right endpoint I'm just going to shorthand that, is 2, 2. My critical numbers were at 0, 0, and my other one was at 1, negative 1/2. So to get your minimum and maximum, my smallest number is negative, you're looking at your y values, negative 5/2 or negative 2.5. So that's your minimum. And your largest y value is at your right endpoint. So that's going to be your maximum. And these are just other critical numbers there. Okay? Thank you. Have a nice day. Bye-bye.